And thanks everyone for coming to listen about Mina. So I'm Evan. I co-founded O of One Labs, which was the dev team behind Mina. And as we got to Mina launch, I split off from O of One Labs with some other folks at O of One Labs and founded Mina Foundation. So now I'm the CEO of Mina Foundation and helping, I guess, on a bunch of things between ecosystem and partnerships and developing the protocol and community and a whole bunch of things. But that's where I sit now. So what is Mina? So we set out to build this cryptocurrency that was to be maximally decentralized. Basically, we wanted to build something that would be very easy for anyone to be able to download it, to check it, and access it in a fully secure way that doesn't depend on any other third parties. We were noticing this was around 2017, and it was the time of like Bitcoin having questions about whether to increase the block size or not. So we got very, very interested from a research and technical perspective. What was the underlying challenges to that, and what could be done to build a technical architecture that wouldn't have the same constraints around block size, limiting the ability for people to download and run this thing. We were asking, maybe it's possible not just to get it so that we can keep it within a few hundred gigabytes. We can actually get it to a place where it can be very easy to verify from a mobile phone or from a browser or from really anywhere. And that kind of line of questioning led us down many paths, but the one that when we saw it, we realized it was a very good fit for this problem is zero knowledge proofs. So what we've done with Mina is we've taken the history of the blockchain and wrapped that all up in a zero knowledge proof that you can download that zero knowledge proof to your device, to your phone, to your browser, whatever, and your client running on that device can effectively act as a full node by checking the entire history with that zero knowledge proof. And in doing so, achieve like real decentralization, real accessibility and security with this small zero knowledge proof. So it's a very light blockchain. We also care a lot about this. You can maybe see from the original motivation of making it very decentralized, we care a lot about making this something that is really powered by its users and can grow into a community of people that are realizing crypto to be something that really allows everyone to have a say over their digital lives and how cryptocurrency is going to run. So we've put a lot of effort into making the consensus something that is also fairly cheap to run. Yeah. Let's see. Okay, so some of the problems I mentioned today are just going through these again. Some of them are new, I didn't mention them yet. So for one, blockchains are very heavy. So this goes back to that thing I mentioned about Bitcoin, where you can increase the number of transactions that get into a block, but the cost to doing so is you're going to be in a place where the blockchain is going to get bigger much faster, and then it's going to be harder to download and verify. And that kind of leads to a question of trade-offs. You can then say, okay, I'm going to ditch the history, and I'm going to have people have to trust some entity to get online, some Infura type entity or something like that. Or you can say, I'm going to keep the throughput relatively low, and then what I'm going to do is limit scale, but at least everyone can access it. And neither of those are great. So this is a problem with traditional blockchain architecture. And so as you increase the throughput, this gets even worse. If you increase it if you want to maintain a proper blockchain, you can see this happened with EOS and Tron. They tried to do this and they increased their throughput to 1,000 TPS. Very quickly, that became a multi-terabyte blockchain, not great for decentralization. And lastly, a really great property of these zero knowledge proofs is what they enable for developers at the smart contracting layer. In particular, that if you want to put data on a blockchain right now, you kind of have this dilemma of, if you want to prove something about that data, you have to make it public because these chains all operate out in the open, everything's executed publicly, which is good from a accountability perspective, but you need tooling around zero knowledge proofs in order to actually get access to privacy for putting data on chain, which is important. So like I mentioned, Mina is based on zero knowledge proofs, which gives some pretty clean solutions to a lot of this stuff. So for one, Mina is very, very light. The proof itself is on the order of a kilobyte or two. And then you get paths down to individual accounts if you're running a full node that's not downloading the whole ledger. And each one of those paths is also just a few kilobytes. So if you want to use the chain, you want to get a proof of the entire history since Genesis that includes all consensus information and isn't requiring any trust at all, and you want to get maybe a dozen paths down to some particular accounts you care about, you can do that in 10 to 20 kilobytes. So that's very good. We have a partner right now working on an implementation of Mina that is written in Rust and compiles to WASM, so that this can actually be a thing that runs on our phones and our browsers, and someday we'll have just a JavaScript library that you download, and that will be kind of it from a developer's perspective and from a user's perspective, because it will connect to a gossip net over WebRTC if you care about the details. The next advantage that we built into this was we're using a variant of Ouroboros, which is something that was developed by the folks at Cardano, but we've made some tweaks to it to both open up the number of validators so that we don't have a cap on the number of validators. It can be as many people that want to. Basically, if you have stake in an account and you want to stake, you can just do it. As well, what was I going to say for this? There's that. And then, yeah, so basically it's very cheap to run these also, because you can just download this very light version of Mina and be able to run a full node without having to be thinking about downloading hundreds of gigabytes to your device to run a node. You can just do it with just downloading one copy of the ledger, which is very cheap compared to the whole history of something like Ethereum, for example. And then lastly, I was mentioning these zero knowledge proofs are very good for putting privacy, verifiability, and large computations on chain in a very efficient way. Usually you have to put the whole computation on chain, all the data on chain, or else you can't really prove anything about it. What's awesome with SNARKs is they allow you to share proofs of a computation instead of the data itself. So I can say, I have this huge database over here, and I applied all these different operations to it. And it turned out that after I did all those and I sorted it, the biggest element was whatever. And you can do that as cheaply as running any other transaction, because doing any of these things on Mina is just the cost of checking a zero knowledge proof. So it's very good when you're thinking about building larger computations on chain. And additionally, with this, we can make it possible so that you can take some information that is off-chain. The one that we're most excited about is HTTPS data and internet data, because there's already sort of enough cryptography around it. You can get pretty close to having trustless verification of websites, and then you can prove facts about it. And to maybe explain why that's cool, and I think I'll get this later in the presentation, I can have a website that has, say, my credit score on it, or something about some transactions I made on an exchange, or something about my social media account. And I can make a proof about that, saying that I actually did post this post to Twitter that got this many likes, or I actually did make this trade that I want to brag about, or I do have this credit score to access this DeFi product. And you reveal the proof of that data without the underlying data itself. So we're excited for this to be able to start kind of linking some things in the real world with cryptocurrency, which we think is going to be one of the main use cases of snaps and SNARKs, and is going to be something that's really good for crypto and ecosystem. So between all these things, like I mentioned, we care a lot about thinking about, are we building infrastructure that will actually enable crypto to be used by a large number of people, to build something that we can kind of operate collectively and really align with our own interests. And I think we started there from decentralization, and we have a lot of work to do. There's like so much things happening on like the fronts of like DAO and all that kind of things. But this is kind of where we want to aim to go with the technology. So talking briefly about where this all started. So I mentioned it started in 2017. There was a lot of developments between 2017 and our mainnet launch in 2021. Primarily, we wrote a programming language to make it possible to write very large SNARK programs very efficiently, more like regular code, which is what we're using now in our programming language for Mina. And then we had a year or two of testnets. I think it was around a year and a quarter to actually get into a state where it was, fully resistant to any easy exploits or any it's like auditing it, and also making sure that as we subject the network to very high numbers of transactions, it's actually remained stable and everything. But we launched the network finally at the beginning of this year. And since then, we've run a community sale. We've had exchanges list Mina. We've split up the foundation to help build the ecosystem from O of one. And we've started to work on a number of exciting partnerships. We're working with Ethereum Foundation on a bridge between Mina and Ethereum to bring some of these zero knowledge proof features to Ethereum. We're also going to do something similar with Polygon and bring this technology to their applications so they can access real world data with SNARKs on Polygon. As well as actually in just a few weeks now, we're going to be having an event teaching Mina's SNARK programmability language snaps in mid-December. And then we actually just sent a sign up link for that on Twitter if you're interested. It's all in TypeScript and JavaScript, which makes it pretty accessible, but it still gives you access to zero knowledge proofs, which is, I think, a first. So it's really cool. I definitely check that out if you're interested in programming with some of the things I've kind of mentioned at a high level for Mina, as well as programming with zero knowledge proofs. And next year, we have some exciting things that are going to happen. We're going to be bridged to Ethereum, and we're going to be able to have the SNARK programmability usable on Mina, and that'll make it possible for Ethereum apps to also integrate a lot of this programmability stuff with SNARK. So it's going to be exciting. So some basic stats. It's been 8 months now since the network has launched. It's been working and stable, which is very cool. We have over 75,000 active Mina accounts on chain, and I don't think we have the stat we were looking at today. I think almost all of them are actively delegating or staking, so very high percentage of actual participation in the consensus, which is good. So what we wanted to do, and over 1,000 connected nodes. We saw, we've seen big swings in network traffic after listing on exchanges or just various things happening in the community, which is exciting, and the network has stayed stable, which is intended, so that's good. Technology is working. And we have over 1,000 core community members and over 200,000 members participating in the Mina community in total. The place to go for the core community is Discord. We have a very active community there if you're curious to check that out. So mentioning a little bit on these use cases I mentioned around zero knowledge proofs. So this is the place we're excited for SNARKs and zero knowledge proofs and snaps to first have a lot of impact. And in particular around verifying data, privacy, putting large amounts of compute on chain. And this is really good if you want to do things such as pull some real world data into a DeFi application, or have an NFT that actually verifies something that happened off chain in a fully decentralized way. You could do something where, for example, you have to prove you own a Twitter account to claim the NFT for a tweet, and there's no centralized entities involved in that except for Twitter. As well as the ability to do some really neat things with trustless bridging. The Ethereum thing that's being worked on actually is verifying the entire SNARK of Mina. So it's really a proper trustless bridge, and there's some cool possibilities between that and other chains as well. As I mentioned, it's all in JavaScript, TypeScript, implementation's underway, and getting pretty close actually to being public and usable and everything. There's this workshop bootcamp planned for December, so please check that out. There'll also be some grant programs on top of that. So if you've gone to that workshop and bootcamp and you know the technology, there'll be opportunities to be able to build things and receive grants for it. So I've mentioned this word snaps a few times. Snaps is snarkified applications. It's Mina's smart contracts. And it has these features I mentioned around, putting things on chain from the internet and data privacy and whatnot. 3 particular use cases that we think will probably be really cool to see built out, and we probably will either incentivize in some way or help build in some way. One is this private access to internet services. So like I mentioned, verifying a tweet on Twitter, proving something about my credit score, proving something about my identity, I think can be a particularly cool one, especially as if that becomes some kind of a stand-in for KYC without actually revealing anything, I think would be really cool. And another one to mention is the actual kind of underlying technology of this that you can access. You probably got from what I said, you can access any website for this. You don't need to partner with them. You can just use HTTPS to be able to do that, which is cool. And lastly, another thing we're excited about is the ability to kind of bring this together and build both single sign-on technologies that let you sign in privately to services, as well as that serving as a wallet that has, you can connect it to all these different private facts about you and put that on applications that Both are on the web and are on chain. So some exciting things there. One partnership to kind of highlight in this DeFi space is this one with Teller, which is basically a snap that you prove your credit score is above a certain number. So in the US above 700, and that gives you access to loans with better rates effectively. So by knowing something about your identity and knowing something about your previous credit reliability, they're able to offer this. And this will be really useful as we think about what can we do in crypto to open up things like DeFi to people that don't just have a lot of capital, people that are just have a lot of social reputation and otherwise should be trustworthy for loans, but probably don't want to reveal their identity and personal information permanently on chain. Being able to use zero knowledge proofs to put this information on chain in a safe way is very useful for this sort of thing. So lastly, you can see some of the people that are supporting us. We have a large community of block producers and people that are engaged in the project. The Mina Foundation, which is generally supporting the ecosystem and trying to think about what we can build for everyone that'll make it easier for them to contribute and help the project, as well as ecosystem partners, including O of One Labs, other ones such as ChainSafe and this other one called OnTab. And there's a bunch of other ones. Nil now is working on the Ethereum bridge. There's too many to mention, but they're all working on programming as well for the actual protocol. So for more info, here is our website, or you can sign up for our newsletter here. Yeah, that's good places to learn about the project. I think our Twitter is good too. You can see that on the next page, more up-to-date, like detailed news there. So that's all I have for the presentation. I'm happy to answer any questions that people might have. Yeah, thank you. I think you're muted.
Oops. All right, I think your Telegram group is also pretty large, right? 50,000 or so. So very good. So if you have any question, please use the chat, raise your hand, or the Q&A box, anything. I'm always, my role is to ask the very stupid questions up front while people get their minds together. So one question up front around all the privacy issues, and Japan has a certain phobia towards privacy coins, right? It's been probably 3 years ago now. The likes of Mona, Zcash, Dash have been delisted and are absolutely not allowed here. And so when we talk about the zero knowledge proof, it's not actually applied to Mina as a coin that is public as to where it holds or which address it is sold. Is that a correct understanding?
That's right, yeah. So the actual ledger doesn't use like privacy technology directly. It's applications built on top of Mina. And we're mostly interested in making it possible to unlock data privacy. So in particular, making it so companies don't have to hold people's data to be able to use their products and putting information on chain in a safe way, and less from a financial like token privacy perspective.
And then the use of privacy for the credit scoring obviously is a very interesting case, but it was also generally phrased as saying kind of privacy preserving access to services. But if this service is now payments or banking, then we again get into a conflict. And there's nothing that prevents anybody to build on Mina a payments or banking service, right?
When you say, what do you mean exactly? Like nothing preventing someone from building those private services on top of Mina?
Yeah, so if I build a payment service or banking service, but I preserve the privacy of the participants in that transaction, then obviously I'm going against AML, KYC regulations. And so that would be not very well regarded by our friends, the regulators.
That'll be on the application developer. What we're thinking will probably happen is application developers will be more interested in A, like building things that are compliant, but B, being able to leverage things like what Mina has built, leverage the privacy technologies of Mina in order to achieve greater regulatory compliance than otherwise. For example, I probably don't want to, as a centralized application, collect a bunch of KYC information, but if I can collect a proof of that, I can still be compliant potentially without having to kind of break some of the core tenets of not having a centralized service on crypto.
Right. There's a similar question, I think, from Karen saying, like, what's Mina's position on GDPR or other privacy obligations. So obviously China came out just with their regulation a month ago. Japan has a refresh next February or March. How does it fit into these regulations?
Yeah, I think it's kind of early, but what I'm excited for is I think we'll be in a place where zero knowledge proofs will provide very elegant solutions to a lot of these GDPR style questions, where maybe if you're a company and you're thinking of collecting all this data and having to follow GDPR for it, maybe it's better to just accept a zero knowledge proof that gets you to the same place product wise, but you don't have to actually hold that data, so you don't have to think about complying with regulations. So I think there's a lot of good I'm very excited for zero knowledge proofs in particular, whether Mina or not, to I think really provide a lot of help in digital privacy in general. And I think things like GDPR will be, future versions will include them.
I think some scheduled questions maybe. You showed the timeline very quickly, so it might have been on there. But when is the snaps on the testnet and mainnet planned for?
Yeah. So in some sense, they're already out on testnets, but they're just like O of 1 doing testnets right now. I think in December with the workshop and bootcamp, it'll be out on a like full public testnet. The actual mainnet release, I think, is going to happen the very beginning of next year after we've gone through this bootcamp and we've gotten a lot of feedback and we've sanity checked this is the right move before actually putting it into mainnet. So I would expect around that timing for it.
Okay. On the protocol itself, so the node is 10 kilobyte. Does this include block data? I guess no. And then who keeps the block data?
So there's three kinds of nodes in Mina. The first is nodes that are downloading the proof, which gives you knowledge that all the transactions are correct and all the consensus information has followed that, including being under proof of stake up until now. So you get that with those 10 kilobytes, which effectively gives you this secure access to the chain. The next kind of node is consensus nodes. And what those are holding is the current balances of all of the accounts of Mina. And if you're writing a program, that's the state you get access to. You can't just like necessarily go back and reference something, 3 months ago, unless you're willing to potentially have that not be available. It's only the current state of accounts. I sometimes think of the metaphor just like it's like kind of like you can only access the current state of your hard drive on your computer. You can't like go access something you deleted 3 months ago. But there is a kind of node as well, archive nodes, that at the moment are possible to run that do hold all the blocks. But I would predict that as if Mina is with snaps because it's a very high throughput, we will probably see people primarily running those first two kinds of nodes, with people running archive nodes over select subsets of the Mina blockchain as per they want to kind of track things, which is an optional activity.
And I think in a Medium article, you compare this to a credit card. So in order to use my credit card, all I need to know is that I'm actually in possession of the card and the credit balance I've accrued so far. I don't need to know all the transactions that came up to that point, which was, I thought, a very good illustration.
Exactly, yeah.
When the network gets larger, and in a way, is there some snapshotting that happens for these nodes that keep the balances? So can different nodes, even simply because of latency, because they run in different parts of the world, have a different state at different points in time?
You mean from like a networking consistency perspective? Yeah, so I think that, well, I guess for one, there's probably going to end up being two parallel gossip nets for Mina. The first is only for consensus nodes, and that will probably be in the realm of a few tens of thousand, just because it would probably be really hard to keep block times low and keep throughput high if we started going bigger than that. And then there will be another layer on top of that, which is all the nodes that are sharing proofs, like our phones and browsers and stuff. And the proof will be very, very small for them, so you can have a much larger number of nodes. I think if you try to go past that, you do run into consistency issues. I think kind of like the limit you can see with this is Solana, where they don't have history as far as I know. They just have kind of people bouncing around the current state, and they're able to get up to fairly high TPS. So I would imagine around there is also the max for Mina. And then you have to think about some kind of sharding using effectively roll-up type things, but that's very future probably.
Good. Since you mentioned Solana, across like Avalanche and Solana, it seems to be the hottest properties right now. And if you look at the investment space, the VC space, it seems like everything that's built on Solana has like a 1.5x or 2x versus a kind of similar functionality built on Ethereum. So there's a certain hype. And in that context, also in one of your Medium articles, I think you've written about capacity versus functionality, and you have 1 transaction per second currently, which is more than enough, you say, simply because you're 1/10 of that or so in terms of utilization, and you obviously have limited development resources, and you rather focus these on functionality than capacity that's not just needed. So it's really what we're seeing across the overall DeFi ecosystem. It's a race to build the largest community in a way, isn't it?
I think so, yeah. I think yes, I think that's right. I think what's happening now is a race to build larger communities. And I think we're starting to see this tech be rolled out in real use cases, which is like extremely awesome. And the way that we're coming into that with zero knowledge proofs and snaps doesn't necessarily require us to have that crazy high throughput quite yet. It's kind of in the back of our minds, like, okay, like, we're doing, I think, an average of somewhere between 0.2 and 0.5 TPS real actual usage right now. Maybe with snaps that'll very quickly get up to 1, and then we'll have to start thinking about scaling it. And then we can kind of keep thinking, okay, we're going to increase capacity, increase usage, increase capacity, increase usage. Yes, exactly.
Good. Thank you. And another protocol, what's the difference and similarities between Mina and Aleo?
Yeah, so I think there's 2 primary differences I think about. One is that, as far as I know, Aleo is using proof of work still, which to me, I definitely feel strongly about some of the environmental concerns of proof of work. It seems like proof of stake works very well for securing a network, and you don't need to burn all that electricity. So anyway, that's a difference with some commentary. The other one is Mina. We focused a lot on recursive zero knowledge proofs. So there's some functionality and applications that you get from recursive zero knowledge proofs that you can't necessarily get if you're not using them. So I think there will be some use case differences. For example, we focused a lot on making this possible to use from JavaScript and TypeScript, which I think is still a difference and something that we hope makes it easier for people to use with Mina.
Another comparison then to Ethereum in terms of the transaction and gas fees. So what's the cost on Mina compared to Ethereum? And if I may add a second question to that, what's the inflation that you get through staking? So what are the staking rewards essentially in percentage of the outstanding?
Yep. So right now it's very cheap for running a DeFi or running a snap effectively on Mina. I think the key here, the way I think about it often is if Ethereum was to increase its block size a lot, then they could have very cheap gas. But if they were to do that, then their chain would go very, very quickly. So they have a fundamental trade-off in how much they can guarantee that the data will be there in a way that you can get to the chain in a decentralized way versus the gas costs. And at the moment, with the way snaps are configured, it's very cheap. But once we hit saturation of 1 TPS, we'll have to start thinking about increasing the TPS of Mina. But hopefully, I don't think we're going to run into the same limitations Ethereum has, because as long as we can kind of increase the raw speed at the tip of the network that Mina is processing, it all gets folded into this history and doesn't have the decentralization trade-off. Yes. So I think, one more thing to mention on this is the cost per validating a transaction on Mina is the same regardless of how much computation is going on. So it's particularly advantageous if you're evaluating a very, very large computation. because the chain is just checking a proof of the computation, which is the same size and dependent on the actual underlying computation. So that's a place where in particular has a big advantage.
And the inflation that you get through staking rewards?
Yeah, so currently it is set at, I think around 12, it's at around 12% if you have an account that is like locked, so if you're like a backer or you're the foundation or something, it's set at that. But if you have unlocked tokens you've bought on the market, it's like 24% at the moment. It's double that. Maybe it's a little less actually. It's going down over time as the it's constant emission at the moment, but the number of tokens gone up. So if effective inflation rate goes down, I think it's around 20% right now actually. And this is going to be reducing with hard forks over time. So it's really intended to make sure at the beginning we had a lot of really good staking participation, which we are seeing very high percentage staking numbers, which through the rewards there makes sense. And as we'll be lowering that over time as we see how much staking rewards are actually necessary to keep that staking percentage really, really high. So at the moment, 20%, but expect it to be a limited time thing.
Got it, thank you. On the Ethereum side, maybe another question. I found it interesting when you talked about the bridge, it was really to expose the Mina functionality to Ethereum. And I think, and I'm not the deepest in all of this, but I think most of the bridges that you've seen were basically saying you've got so many assets on Ethereum, I'll build a bridge to basically wrap the assets and bring them onto my chain, and then I can do all the DeFi stuff on it. So you're actually doing the reverse in terms of functionality, which is super interesting. But what would you see kind of similar to the examples that you've given here? What would an Ethereum DeFi builder use the exposed Mina functionality for?
Yeah, so a bunch of examples. Maybe, for example, I want to build a DAO for all my Twitter followers. And on Mina, I can produce a proof that I follow someone on Twitter, or maybe that I've actually followed them for 3 months now. So I'm a longtime follower. And then the DAO can live on the Ethereum side, but the DAO is looking at the smart contract address that contains the proof of Mina state. And then what it's doing is when I want to join on the Ethereum side, it's checking whether or not that Ethereum address is also on the Mina side, proved that it actually is a follower of that person, at which point perhaps it can join that DAO for that person. So yes, I guess that's not quite, it's kind of DeFi, it's like DAO, but you can go from there too. You can imagine, like I think Teller, for example, is building on the EVM Ethereum side, and they're also going to look at the smart contract that pulls in the Mina state that shows my credit scores, whatever number they want to prove it is to access their smart contract.
Now, I wonder whether we also get a bit into the Oracle problem simply. So with the example of Twitter and the Twitter followers and who's the follower, the source is pretty clear to define, but for other oracles, there might be malicious actors if you have price feeds and so on. So how do you make sure that it's correct and authentic what you get in terms of the proof?
Yeah, so for the Twitter example, we assume that the Twitter API isn't going to lie, basically. And then what we do is we have a proof that says there was a protocol that happened between this client and some other parties and the HTTPS endpoint on Twitter, that the HTTPS endpoint on Twitter delivered a certificate that boiled back up to a root certificate, and the data was, well, the symmetric key was derived from the actual real Twitter identity. And then there's something that happens where then you can show that you can hide some of the symmetric key. Anyway, I'm going to deal. But basically, we assume that the Twitter is not lying, and then use HTTPS with some other tricks to get that data on chain in a way that is fairly trustless. If you wanted to pull something else on chain that is from a source you maybe don't trust, maybe, for example, there's like a Reddit subreddit you're getting your price feed from or something like that, then you're going to run into problems. But it really will depend on how much you trust the website And then as well, I didn't get into details of this, but how many different parties the client verifies their HTTPS transaction with on the backend.
Yeah. So maybe a side effect of that bridge will be you'll be known as the chain link killer in the future.
Maybe.
There are two more implementation questions here. One is about the Rust implementation availability on the mainnet.
So this is what ChainSafe is working on, and what they're building right now isn't going to be, at least at first, a full consensus staking node. It's going to be this node that just gets the few kilobytes proof, gets paths down to individual accounts, and can be used from your browser and other devices. So I think that is something that I don't remember their exact timeline on, but I think during sometime next year. I want to say in the first half of next year. The dream for that is that as snaps go out on mainnet, people would write their applications, and then very soon after that, it would be possible for a developer to deploy a snap application via the ChainSafe Rust node that runs in the browser. Thereby, you have this setup which a developer just deploys code. They don't have to find some Infura backend or anything to do anything. It's just trustless in the browser. So I don't know when exactly, but that's an indication of perhaps about-ish when.
Got it. Will Mina support layer 2 chains?
So I think for a while, Mina will kind of be a layer 2 to a lot of these chains. It'll be something that you can fully verify it on places like Ethereum. I think that where Mina might start to get L2s, which will be really interesting, is one, if people build rollups faster than we scale up the actual core TPS of Mina. It's very easy to build a rollup on Mina. It's like a few lines of code to build a zk rollup, which is very, very accessible, and it's like straightforward code too. It's written in TypeScript. So I predict people will build these, and yeah, it definitely supports it at least. Yeah.
And maybe that's a counterintuitive question, given that we're all fancy blockchains, but kind of zero knowledge proofs have a wide application in finance or any other industry as well today, whether it's on a blockchain or not. So and maybe right now the addressable market outside of blockchain might be bigger, and maybe in 5 years that will inverse. But any thoughts around actually making the technology available outside of a blockchain?
Yeah, so the end dream of this is that Mina is something that's going to be more thought of as a primitive to be building zero knowledge proofs on the web versus, it's a cryptocurrency, which is necessary for it to have data, and it'll be doing a lot of financial things, but it'll just be a generally useful library for building web applications that deal with user privacy in good ways and get access to other primitives of a blockchain in a useful way. I think the other half of that is, and this kind of connects back to the layer 2 thing, is there's a lot of good potential for enterprises to build private L2s that don't drop the data into the blockchain, but are fully verified and drop a proof of that data into the blockchain. So a company running a side chain, which is doing a bunch of things with privacy and then posting back proofs of that to the chain in a secure way, which meets like some of the privacy needs enterprises have. There's another place I think it'll plug in over the next few years.
Good. I think this is the last question we might have here. Is going back to staking, but is the staking basically proportional to the number of coins staked?
Yeah, so yes, with variance, if you have smaller, like if you're only staking a few hundred Mina, you're gonna do that with high variance. If you're staking a large number of Mina, you'll win more blocks, you'll have lower variance. But yeah, it's effectively proportional to the stake you put in. Oh no, wait, sorry, did they say 0.1% gets like 0.1% yield? Or Basically, if you put in 100 Mina, you should expect at the end of the day, if it's 20%, to get 120 Mina afterwards. I forget if I answered it correctly or if I misheard it the first time, but effectively,
I think that's how it was intended. So
okay, cool.
That's good.
Yeah.
Otherwise, otherwise it wouldn't make too much sense.
Yeah, it's like yeah, I was like scratching my head for a second. I was like, wait, what I said doesn't really. Anyway, yeah.
So obviously, we're not giving financial advice, etc. But if you were now fully excited and wanted to buy some Mina, then Binance is probably the largest market where you can access it.
Yeah. Yep.
So do your own research and due diligence. Not listed in Japan yet. Do you have anybody working on that by any chance, that you get through the thicket of administrative and governance items here to get it on one of the 30 Japanese exchanges?
I don't have any news at this time.
Yeah, it's probably a costly undertaking, so that might be lower hanging fruit. The insider question is, of course, when do you get on Coinbase?
I don't have any news at this time.
Good, super. This was super interesting. Really appreciate you taking the time on Thursday night. It's very funky with these West Coast to Japan time differences, but I think this was very good, and we have the recording. We'll make this available to us. I'm sure lots of people will follow up and listen to that there as well. So thank you very much, Evan. Thanks to the team. Sherry was hard at work here, managing the questions and getting everything set up. So thanks for that. And John Robinson, who's part of the Tokyo FinTech community and brokered this in the first place. So thank you all. Thanks for joining. Thank you, Evan.
Yeah, thank you. And thanks everyone for the questions as well.
All right. Thank you. Have a good night.
Good night.